Hello, my name is Austin Erickson. I'll be presenting this paper titled Effects of Transparency on Perceived Humanness, Implications for Rendering Skin Tones Using Optical See-Through Displays. I'm happy to present this on behalf of my co-authors Tabitha Peck, Jessica Good, Isaac Bynum, and Gerd Bruder. Optical see-through augmented reality displays such as the HoloLens 1 and 2 and the Magic Leap 1 use what's known as an additive light model, where light from the display is added and mixed with the light from the user's environment. The additive light model comes with several disadvantages. One is that the display typically cannot render the color black. Since black is the absence of light, light would need to be subtracted from the physical environment as opposed to added to it in order to create a region in the scene that appeared black to the observer through the display. Because of this, when attempting to view anything designed to appear black on an optical see-through display, it will appear completely transparent, as if it wasn't rendered at all. This transparency problem extends to all colors capable of being shown on optical see-through displays, where the perceived transparency of a uniformly colored virtual image decreases as its luminance increases. However, even if rendering at the highest luminance white light that the display can manage, the image may still appear semi-transparent when displayed in front of a non-uniform physical background, depending on the contrast between the environment light and the displayed light. This effect is sometimes referred to as color blending. Past research has typically investigated how these problems affect user perception of user interfaces, where increased transparency can cause decreased legibility of text and decreased performance in visual search tasks. This makes designing UIs for these types of displays difficult. However, this problem may potentially extend to other types of imagery shown on optical see-through displays besides just user interfaces. For example, we have an entire session at this conference dedicated to virtual humans and agents, and these virtual humans can be comprised of many different colors depending on factors such as their skin tone, clothing, and virtual lighting. This led us to the research question that motivated our current work. How does perceived transparency affect user perception of virtual humans shown on optical see-through augmented reality displays? We set out to investigate this research question by conducting an exploratory crowdsourced user study using the Cloud Research platform. In our study, we recruited 160 participants who were tasked with observing images of virtual humans at varying levels of opacity. Participants rated their perceptions of the virtual humans according to how much they thought keywords and short phrases applied to the person in the image on scales of 1 to 100. A subset of these keywords and phrases was determined using principal component analysis to create a measure of perceived humanness of the people in the images. The study involved 3 independent variables: opacity level, appearance, and model. Opacity level would vary the opacity of the virtual human compared to the background of the image at 4 different levels. Appearance would vary the virtual human in the image between a virtual 3D model and images of real faces obtained from the Chicago Face database. Finally, the model in the image would vary between a white male, a black male, an Asian male, and a male zombie, where zombie images were included as a means of verifying our measure of perceived humanness. This required generation of 32 total images for use in the study conditions. In order to establish a level of opacity that would be representative of what the observer would see on a current consumer AR HMD, we performed a perceptual matching task with a HoloLens and a flat panel display. A user was tasked with modifying the opacity and layer blending parameters in Photoshop to best match the appearance of a virtual human between the 2 displays. The results of this task indicated Photoshop values of 35% opacity with additive layer blending to best match the appearance between the images in our testing environment. These values were used for the lowest opacity level tested in our conditions, and the other opacity levels were set at even intervals between 35 and 100%, with a final condition testing the control case at 100% opacity level with normal layer blending. The results of the study indicated that perceived humanness measure was accurate at establishing differences between images of zombies, images of avatars, and images of real people. With our measure confirmed, we saw that the opacity level has a significant main effect on the perceived humanness of the people in the images, where increased opacity results in increased perception of humanness. The implications of these results are important for applications involving virtual humans on optical see-through displays. Since opacity level is directly related to the perceived humanness and darker colors appear less opaque than lighter colors on these displays, it implies that there will be an unintended racial bias in the presentation of virtual humans, where virtual humans with darker skin tones have lower perceived humanness by observers compared to virtual humans with lighter skin tones. Unfortunately, as far as display technology goes, it appears as though this will remain a problem for the foreseeable future, as research into subtractive or light attenuation optical see-through displays is still relatively early on. This means that we need to be aware of this problem moving forward, and we need to look for other potential strategies for eliminating this bias. There's still a lot of work to be done in this area. Our exploratory study investigated static images that were shown on users' personal displays and not actually on optical see-through AR displays. So we need to confirm that these results transfer over to the various optical see-through displays that are common to our field. Additionally, it remains to be seen if user perception would change in the presence of other variables, such as dynamic virtual avatars or in specific applications such as video conferencing. Thank you very much for your attention. I'll be around to answer any questions that you may have.